Hi Math 215 students. In this video we're going to talk about some warnings for matrix multiplication. Before moving on from the video, please do your best to explain why matrix multiplication is not commutative and recall the other warnings that we're going to talk about now. So to put up the beginning that we've had for the last couple of videos, if we define what we mean, it is possible to add and subtract and to multiply matrices together. We talked about multiplication last time and how that's accomplished. We're going to talk about some problems that can arise when you're dealing with multiplication. We'll finally answer in this video why division is not included in the list. So let's review the matrix multiplication properties we ended with in the last video. Matrix multiplication is associative, follows some left and right distributive laws, and has a nice interaction with scalars, and there's an identity. Multiplying by the identity matrix does the same thing that multiplying by 1 does for numbers. There are some differences, though, between numbers and matrices, and we're going to talk about 3 particular differences. So if you like, go ahead and try to answer each of these questions. 4762 times 358 is 1,704,796. So 358 times 4762 would be what? 593x equals 593 times 14, so x must be what? And if x minus 3 times x plus 2 is equal to 0, it must be true that what? Okay, well, let's dive into these. The first one, if 4762 times 358 is the number there, then 358 times 4762 should be the same thing, right? The order that you multiply two numbers in doesn't matter. If you were to switch the order, you end up with the same answer either way. Now here is a warning for matrix multiplication. It does not necessarily give you the same thing. For example, if we were to take 5, 1, 3, negative 2, that 2 by 2 matrix, and multiply it onto the 2 by 2 matrix whose entries are 2, 0, 4, 3, go ahead and pause the video if you like and figure these out. But doing that, we'll end up with this matrix, 14, 3, negative 2, negative 6. Now on the next line down, we've got the same two matrices, but they're in the opposite order. And if we multiply those, we end up with what looks like a completely different matrix. They're very different, these two answers, but you used the same two matrices. The only thing that changed was the order that you multiplied them in, but apparently that can make a difference. So in general, multiplying two matrices AB and BA will not usually give you the same result. Okay? And if you think about it, there's really no reason why matrix multiplication should be commutative, right? Commutative is what we call this property when multiplying in a different order gives you the same result. So matrix multiplication is not commutative, and that's because the first and second matrices play different roles in the multiplication. You might remember from the previous video that using the row-column method to figure things out, we start first off by checking the sizes of the matrices. You're only allowed to do matrix multiplication if the number of columns in the first matrix is the same as the number of rows in the second matrix. Or in other words, the two middle numbers, if you write their dimensions next to each other, need to be the same. So it is possible to multiply a 2 by 3 matrix and a 3 by 4 matrix. If we were to try to multiply these matrices in the opposite order, orange matrix followed by green matrix, 3 by 4 followed by 2 by 3, we'd see that the 3 by 4 and 2 by 3 don't work. The 4 and the 2 wouldn't match up. So it's actually not even possible to multiply these matrices in the opposite order. Another reason why you wouldn't expect to get the same thing is because each entry of the answer this way was formed by going across a row of the green matrix and down a column in the orange matrix. If we were to switch the order and multiply the orange matrix before the green matrix, we would be going across a row of the orange matrix and down a column of the green matrix. And the columns and the rows aren't interchangeable. They have different numbers. Okay, so said it more simply, these matrices were ones where you could actually switch the order and multiplication was at least possible because they're 2 by 2, the two middle numbers work either way. However, to get that -6, we take 3 times -3 and -2 times 0 and 3. To get the bottom right entry here, we take 4, 3, and 1, -2, and the 4, 3 showed up here, but we didn't use it. We actually used a column in the earlier multiplication. Okay, so matrix multiplication is not usually commutative. Now, that said, we're not saying that it never is commutative. There are some matrices that you can multiply in either order, and you'll get the same answer. So this line gives you an example. You get the same answer multiplying the two matrices in either order. Here's another example. You should maybe stop and check this, but multiplying these two diagonal matrices gives you the same answer whether you multiply them the one before the other or switch the order around. The diagonal matrices give you the same answer. And it's certainly true for all matrices that if you multiply by an identity matrix on the right, or if you multiply by the identity matrix on the left, and this is assuming that the matrix is a square matrix, but either way, you'll definitely get back the original matrix, and so the identity matrix commutes with any square matrix. Okay, but in general, AB usually does not equal BA. So one more example for you to take a look at. You'll see that there are definitely patterns in these two ways of multiplying, and the patterns kind of come from the entries of the two matrices involved. But the important thing for us here is that they're not the same answer. You don't get the same computation if you switch the order of the matrices. Okay, keep that in mind. That's very important. But let's move on to another oddity about matrix multiplication. With numbers, you can solve simple algebraic equations, 593x equals 593 times 14, by just sort of canceling something that's multiplied on both left and right. So since 593 is multiplied on both left and right, we can cancel that and just get x equals 14. Another way to think about that might be to divide both sides by 593. And if you did that, on the left you'd get x, and on the right you'd get 14, so x is equal to 14. Now let's take a quick look at two multiplication problems. If you like, go ahead and figure these out before we move on. But in the first line, we've got a matrix times the identity matrix, so that's pretty simple. The answer to that should just be the first matrix. Now let's take that matrix and times it by this matrix 3, 6, 1, 4. And if you do that, you will end up getting the same answer. And if you want to check, you'll see that, yes, this 8 comes because -4 times 6 is 24, plus -24. 8 plus 4 is 32. -24 plus 32 is indeed 8. And if you were to check the other three entries, you'll see that we do get the same entries, even though this matrix is clearly not equal to the identity matrix. So that's a little bit weird. And if we put these together, if we set these two left-hand sides equal to each other, we have kind of the same setup we had before. We've got something times one thing, that same thing times another thing, and we're able to conclude they're the same, except that here, the identity matrix and 3, 6, 1, 4 are not the same, so we could not just cancel out that first matrix. Even if AB equals AC in matrix multiplication, you cannot automatically conclude that B is equal to C. Okay? So don't do canceling without better reasons, just than that it looks like something you could do in algebra. Now, we mentioned one of the questions we would visit in these videos is why is division not included in the list? And here is one of the reasons why. We said that if you were to divide this equation by 593, the answer, or the equation x equals 14 would just pop out. There is no way to divide by the matrix -4, 8, 1, -2. There shouldn't be. If there was, if we could divide by that matrix, then we would arrive at the nonsensical equation that 1, 0, 0, 1 equals 3, 6, 1, 4. So that's not a good outcome. So we don't expect that there should be any way to divide by that matrix in this equation. All right, so there's no division because it would give you incorrect statements. But we're going to say a little bit more about this in upcoming videos. In the very next section, section 2.2, we'll come back to this question about whether quote-unquote division should be possible. We'll see why it's not a good idea, but we'll see why in some cases you could almost think that it is. Okay, for our last warning, let's take a look at this equation. X minus 3 times x plus 2 is equal to 0. Now, back in Algebra 2, you were solving quadratic equations, and this was the way that you liked to do it. You liked to take your x squared minus x minus 6, and you like to break it up into two factors with the other side equal to 0. Because if you can say that one thing times another is equal to 0, then that means that one of the individual things has to be 0. If x minus 3 times x minus 2 times x plus 2 is equal to 0, then either x minus 3 is equal to 0 or x plus 2 is equal to 0. And back in the day, you could then solve x equals 3, x equals minus 2 would be the solutions for the quadratic equation. Now, here is an idea that's not going to carry forward into matrix multiplication. If we take this matrix times that matrix and do that multiplication, you will end up with a 0 matrix. It's pretty surprising, but if you check, you'll see that it actually is the case. So I have two matrices, neither one of which is a 0 matrix, but when I tie them together, I do get the 0 matrix out. So it's kind of like this setup. I've got one thing times another equals 0, but it's not the case that this matrix or this matrix was the 0 matrix. So we can't get the same conclusion as we did in algebra. Even if A times B is the 0 matrix, that does not mean that the A is the 0 matrix or B is the 0 matrix. So this gives us another reason why division should not be in our list of allowed operations by default. If we could divide by either one of these matrices, we could maybe divide it away and we get the 0 matrix divided by the matrix. But then that would tell us that something that is definitely not the 0 matrix is equal to the result of 0 divided by something, and that doesn't usually make sense. So we should not be able to divide by either this matrix or this matrix in this equation. But we'll say more about that. It turns out that there is a property of matrices that these two matrices don't have that allows you to say a bit more. So we're going to add a few caveats to our list of matrix multiplication properties. These are things that you can do without worrying about it. They're valid. These are things that you need to be careful that you don't accidentally do without thinking about it. Don't switch the order of matrix multiplication unless you have a very convincing reason. Don't cancel a matrix from both sides of an equation unless you have a convincing reason. And if AB is equal to 0, you normally can't say that A is 0 or B is equal to 0 unless you have more information. All right, with that, we've talked a little bit about why division is not included in the list, but we will say more in future videos. And in our last video coming up, we will talk about more operations on matrices. So we'll see you there. Before you leave, please take another look at this outcome, and we'll see you in the next video.